ABCD is a quadrilateral. The midpoints of its sides are PQR and S. Use vectors to prove that PQRS is a parallelogram. Um, so what we need to prove is PQ. So if I have that's PQ is parallel to SR. So it's vector PQ and vector SR. So the direction is the main thing here. So we have the direction of PQ, like P to Q, equals S to R. So it has to be same. So I can write that we have to prove PQ, vector PQ equals vector SR, and we need to prove vector SP equals SP would be this way and RQ would go this way, would equal vector RQ. So if we start with PQ, then we can write, so we'll first do the directions. So PB plus BQ equals PQ, and if B to Q, so Q to C, it would also be in the same direction, and then we'd have RQQC. So RC, it would go this way, R to C. So DR, let's make it this, same as R to C, D to R. And then SD, so it's SD. And AS, of course, is going to be that. And AP will be in this, AP and PB will be in the same direction. So therefore that's so we've determined the directions now. So then let's start building our proof. So we got to first write PB plus BQ, that would equal, they're all vectors, PQ vector PQ, and therefore PB can be written as half of AB plus BQ can be written as half of BC, and that equals PQ. So there's one thing I haven't drawn yet, and that's we have to draw these, join these points AC and BD. And AC is A to C, so that's A to C direction, and BD or DB, we will make it parallel, so to QR, so therefore it's going to be all in pointing upwards, so D to B in the same direction. So you see P to Q, A to C, S to R, and S to P, D to B, R to Q. So these arrows are important because otherwise I think our proof will be all messed up. So that's what we do. A half AB plus half BC is PQ, or we can write PQ equals half times AB plus BC. Now AB plus BC is AC, so PQ equals half AC. So that's PQ. Now if I can say the same about SR, so I can write SR equals SR equals SD plus DR, SD plus DR equals SR. So SR would equal SD is half of AD plus DR equals half of DC, not CD, DC, okay, because of the arrows. So then that is half of not did I say right? dr is half of dc here. So half of ad plus dc plus that's ad plus dc, and that would equal half of ac. So we have now proved that SR, so therefore SR is half of AC. So we got the other one proved. So now we've proved that, so we can say therefore PQ is parallel to SR. So vector PQ, sorry, that's not the right thing to say. I say therefore PQ, vector PQ equals to vector SR, and therefore PQ is parallel to SR. Right, so I got that. Now comes, what do we do SP and RQ? In a very similar fashion we'll be doing it, but a little bit will change because of the directions. So we can write AS, when we're doing SP, we write AS plus SP equals AP. So we can write AS plus SP equals AP. Yeah, AS plus SP equals AP, and we can therefore write SP, keep it on the left hand side, equals AP minus AS, and that equals AP equals half of AB minus AS is half of AD, so half of AD, and you see that is half of AB minus AD. Now what is AB minus AD? So when if we try to write AD, you see AD plus DB. So if I write down here that you have AD plus DB, not the directions, AD and DB, A to D and D to B, that would equal AB, A to B. So we can write AB minus AD, or we can write DB equals AB minus AD. Okay, so therefore you see we can now use this dB, we use this here, so we can write that equals half of dB. So we have now got SP is half of dB. So that's second one, the other third side. Remove the third side equals the fourth side, or whichever way we take it. So SP we've got is half of dB. So we have now got to prove that QR is also equal to half of dB. Oh, I didn't write that. So I should write it that we need to join dB and AC. So that has to be done before that. So the next one is we got to start with RQ. If you start with RQ plus QC is RC, so we will write RQ plus QC equals RC, and RQ therefore would equal RC minus QC, and RC is half of DC minus QC, that is half of BC. So that equals half of DC minus BC. And from here we can see, we can if you look at, you can write again from this diagram that DB, you can also write DB plus BC equals DC. We can write DB plus BC equals DC. So we can write DC minus BC again. DB equals DC minus BC. So we are reading it from the other sides, like, you know. So if you do that, then you can rewrite these vectors a bit differently. If you look at it, once we look at it from the left side, where we were taking AB and AD, and now we are looking at the right side because it is QR or RQ we are dealing with. So we write DB in terms of DC and BC. That it's DB, of course, is DC and minus BC. So if you do that, then you can write RQ equals half of DC minus BC, that is DB. So I think that's done, because that means, see, what we got is, we got SP and we got RQ. So we can say SP equals RQ. Vector SP equals vector RQ, and therefore we say that SP is parallel to RQ. So SP parallel to RQ and PQ parallel to SR, and we have proved that PQRS is a parallelogram. PQRS is a parallelogram. Okay, so that's proof.